Welcome back to Bazai. Sharding a cache or key-value store sounds easy until nodes are added or fail. A naive mod n hash forces almost every key to move when n changes, which thrashes caches and melts networks. Consistent hashing fixes this by mapping both nodes and keys onto the same circular hash space, the hash ring, so only a small, local slice of keys moves when the cluster changes. Hash space and ring. First, hash each key into a number from 0 to m and place it on a circle. Hash each node's identifier too, like its IP plus a salt, and place nodes on that same circle. To find a key's home, walk clockwise from the key's position to the first node. That node owns the key. This simple rule preserves locality and avoids global reshuffles. Adding a node. When a new node joins, it claims the keys between its predecessor and itself on the ring. Only that wedge of keys moves, everything else stays put. This makes scaling out predictable. Traffic rebalances gradually, and warm caches elsewhere remain intact. Removing or failing a node. If a node leaves or fails, its keys shift clockwise to the next live node. Again, movement is local to the missing wedge. With replication, neighboring nodes hold backup copies, so reads continue and writes can repair the missing range. Virtual nodes, vnodes. Real clusters have uneven hardware and non-uniform key distributions. Virtual nodes solve this by hashing each physical node into many positions on the ring, n0_0, n0_1, n0_2, etc. More vnodes per strong server means it owns more smaller slices, which smooths load and reduces hotspots. Vnodes also make rebalancing finer-grained. Losing one machine scatters its vnodes across many neighbors instead of dumping load on a single successor. Operational tips. Choose a stable, fast hash, e.g. xxhash murmur, and a large ring space to minimize collisions. Use per node salts to randomize placements. Don't rely on raw IPs alone. Replicate each key to the next are -1 nodes clockwise. Reads can quorum from any. Writes can use write quorums for durability. Monitor ownership distribution and key skew. Increase vnode count or apply key prefix normalization if hot partitions emerge. On scale events, throttle handoff to cap network and storage I/O. Pre-warm caches for hot ranges if possible. Where it's used. Consistent hashing underpins large caches, NoSQL stores, object storage, and streaming systems, memcached rings, Cassandra/Dynamo-style databases, distributed logs, and reverse proxy load balancers. The result is the same: add or remove capacity without a full reshuffle. If this helped, like and subscribe to Bazai.